Continue daily challenge. So today we're solving the hard task, minimum cost path with teleportations here. So we're basically given an integer array 2D, and we need to find the path from the top left cell to the bottom right cell. And we can use normal moves or teleportation here, so that's the main difference here. So we're going to implement the Dijkstra search here. So let's start with our implementation. This one is defining just some length of row and column here. So grid 0 we need. Okay, next one we are going to memorize all the cells here. So we need index and we need counter, let's name it count like 0. So let's start our for in range M, for J in range N, and let's append release to this one, and we need grid IJ and IJ coordinates, and here like this IJ is equal counter plus 1. Next step, we're going to calculate all the distances here. So we need a lot of cycles here. So first one is infinite multiplied by k plus 1 for in range n, and all of this is in range m here like this. So yeah, and also we need to set the distance of initial one to 0 to 0. Okay, and we need the array to track our teleportations if they were used already, multiplied n for in range k plus 1. The next one is our Dijkstra iteration here. So we need to define the initial one, initial call. So let's define like this, and let's implement our Dijkstra search algorithm here. Let's start with a check. So nipt ij def, and we're going to use this heap library, heap pop, like this, and we're going to check if cost is already greater, so we don't use it. Found already the better path here, so we're just skipping it as a continue here, and we're doing the usual iterations. So let's scroll a bit for bigger window, and so we're doing simple iteration here. It's the bottom one we implemented and to the right one. So let's start pretty similar algorithm here. Plus grid I j plus 1 if and c is lower, dist I j plus 1 t, and I j plus 1 here, basically the same, and also adding it to heap push, and so the same here, j plus 1. As a small optimization, we're going to use teleportations here, so to find more optimal path here. So basically it's simple down right, and here we're doing teleport, yeah, in this case, and found ij. So if teleport used, we just skipping in this case, let it be continue here, and assign teleuse marking as used here, so true. And if cost is lower, then we're okay with this as y t plus 1, and the distance plus 1 is equal to cost, and he push cost x y t plus 1 here, and the result here will be minimum of this one. So let's start, let's try to submit to see if it works. Maybe not, maybe we got some error here. Okay, so we just got a small issue here, it's not a but J here, so let's try one more time and see if it works, and it's accepted. And let's try to submit our Dijkstra search algorithm with optimization about teleportations here, and let's see if it works. Maybe we got time limit exceeded. So our optimization with pointers doesn't work, so we're going to replace it with another one with just pointer of k plus 1. So in this case we're going to replace this completely with new solution here. So we're going to move the pointer here, let's call it length cells, and cells of pointer t plus 1 is lower than b, and in bed to push pq and our cost x y t plus 1 and assign pointer plus 1, adding one more time. So let's see if it works now. Let's try to submit and see if judging works. Yeah, we got the solution accepted. So thank you guys for watching. See you next day.